All right, so this is gonna be number 4 from your review. Okay, and we're doing now, we're moving into the reciprocal of quadratic functions. So you'll notice these are all kind of like 1 over x squared kind of stuff, right? So all this question is asking us to do, not graph it, just simply state the vertical asymptotes of each function and then state the domain, okay? Not even the range. So that's gonna stem, the domain is gonna stem out of what are the acceptable x values that you're allowed to plug into these things so that to get out y's, right? So that's going to affect what you write for the domain. So for A, all I'm going to simply do is just state like what the equations of the asymptotes are, the vertical ones specifically, because then I can dictate, use that to dictate what the domain, the acceptable domain is going to be. And so in this, the restrictions are going to come from the vertical asymptotes. And I know they're vertical asymptotes because they're still left in what we would say maybe is our simplified expression. So we're going to say x minus 3 can't be 0, and x plus 4 can't be 0. And so x can't be 3, and x can't be negative 4. So if I were to write the domain of this thing, you could say it in a couple different ways. The domain, you could use set notation and say x can be everything, a part of the real numbers, such that x can't equal 3 and negative 4. If you were into or you liked using interval notation, you could say it could be everything. You could write the domain like this. You could say x is a part of the real numbers on the intervals, negative infinity to negative, oops, you don't need squiggly brackets, you just need round brackets, negative infinity to negative 4, and then negative 4 to 3, and then 3 to infinity. Okay, so that's how you would tackle these problems. I think the difficulty really just comes down into the identification as to what the or where the vertical asymptotes are. Okay, so for B is going to be the vertical asymptotes here are going to be x plus 3 squared cannot equal 0. Okay, and so you're going to say x plus 3, if you were to square root both sides, x plus 3 can't be 0, and so you have a point in time this time. Sorry, x can't be negative 3. Okay, so you're going to say, okay, I know that x can't be negative 3. Okay, but it can be everything else. So you could say the same thing as last time, really. X is a part of the real numbers such that x can't be negative 3. Or in interval notation, you could write x is a part of the real numbers as long as it's negative infinity to negative 3 and negative 3 to infinity. Okay. And the last one, C. C is a little trickier. I'm just going to write the vertical asymptotes are going to occur from where this thing, x squared plus 8x plus 12, x squared plus 8x plus 12 can't equal 0. And so I'm just going to factor that. I'm looking for two numbers to multiply to 12 and add to 8. That's going to be 6 and 2. And so you're just going to have x plus 6 times x plus 2 can't equal 0, which means x plus 6 can't equal 0. And x plus 2 can't equal 0. Okay, so x can't be negative 6, and x can't be negative 2. Okay, so that means the domain. Again, x can be a part of the real numbers except for negative 6 and negative 2. Okay, that's interval notation, and then this, or sorry, that's set notation, and interval notation would say x can be everything as a part of the real numbers in the intervals of negative infinity to negative 6, negative 6 to negative 2, and then -2 to infinity. Okay, that's pretty much it. Not much more to say about that. I mean, that stuff's important so that you can actually produce the graphs afterwards. You have a bit of a visual representation as to the acceptable inputs into the function in order to get acceptable y values out.